In this video, we're going to take a look at vectors in 3-space. And so you'll see at the right here what this coordinate system for 3-space actually looks like. And you'll see that there are three axes. We have an x-axis, a y-axis, and a z-axis. And which one is which depends on how you're, of course, looking at it. But we could think of our y-axis and our z-axis as sort of normal, x and y. And then we have this axis that's coming out at us, so picture it pointing out at you through the page and back into the page. Okay, and today we're going to look at plotting vectors and points in this coordinate system. So first we should know that each point is actually called, instead of an ordered pair, they are called ordered triples or triplet. And that, of course, would be some point A, comma B, comma C. Okay. So you have different planes in this space. So a plane that contains two of the coordinate axes is known as a coordinate plane. Okay, so for instance, we have, let's say, this one. If you can visualize it, this would be the XZ plane. So those are called coordinate planes. The plane containing, for instance, the x-axis and the y-axis would, of course, be called the xy plane. Okay, and the other two are, of course, similar. For instance, then, a point that is -4, 0, 1, remember that this is x, y, and z, would be part of the xz plane. In order to plot a point in 3-space, for instance, A, B, C, okay, we're going to look at the axes, and it's important to remember the positive direction of the axes as above, and you just sometimes want to highlight it so you understand. So the x-axis, the positive direction is coming out at us, the y-axis is sort of to the right, and the z-axis is up. Okay, so in order to plot that point, A, B, C in 3-space, we're going to move, let's say, A coordinates along the positive x-axis, B coordinates along the positive y-axis, and then C up, right? Or along the z-axis in the positive direction. And that helps us to arrive at, let's say, our point here, P. So that would be the point P, which is A, B, C. And then this line right here is the vector. Okay, and we'll talk more about that as we continue. First, we're going to just make sure we can plot those points and those vectors. And you'll notice this is another diagram with a rectangular prism or a box to help you visualize that, and we will do that as well. Okay, so we'll start by interpreting and stating the coordinates of each point, a little bit easier than actually plotting them yourself. So just looking at our first one here for our diagram, you can see this is the x-axis, so this would be 1, 2, 3, and 4, and moving backwards right into the page. This is -1, -2, -3, -4. And then we have our y-axis. This is the right side is positive, 1, 2, 3, 4. And you can figure out the rest. And the z-axis is our 1, 2, 3, 4. Okay, so this point you'll see starting from the origin. Okay, we traveled 1 on the x, and then -1 or left on the y if you like, and then up or down nothing, and so the z coordinate is 0 there. Okay, and reminder that this is the point that we're talking about. And the red lines are just me sort of tracing the path to get there. Okay, so pause the video and see if you can do B on your own. Okay, so from the origin, I'm going to trace the path starting at 0. I'm at 3 on the x-axis. On the y-axis, I'm negative, and you can just sort of, you can measure what you have up here if that helps, or the box helps you to see that we're at -1, 2, 3, 4. Okay, so just for our records so far, I have 3, I have -4, and now I'm just going to check how many up I have. Again, you can just take that distance and you can measure it on the z-axis using your ruler, or you can see that it hits the z-axis, the box, at 2. And that's +2, sorry. So that's the coordinate of that point right there. Let's say we call it B. So try the next two on your own, pause the video, and then restart to see if you got it. Okay, so for C, to get to that point right there, we've gone -1 in the x, we've gone 2 to the right, and then up, also 2. So that's the coordinates at that point. For D, I'm going to show you how to look at it just a little bit differently. You can look that it hits the box, this rectangular prism, hits the x-axis at -2, hits the y-axis at -1, 2, 3, -4, and then hits the z-axis right here. It's the top of the box, if you can imagine that, and that's a 1. Okay, that's another way to look at it, or you can trace the path with these blue lines as I showed you. Okay, so now we're going to look at actually plotting the points ourselves, and this is a little bit harder. And the thing I need you to understand as we do this is we're taking a 3-dimensional idea here, and we're plotting these on 2-dimensional paper. So it is sort of a model or a representation, but instead, really these points are like in the middle of the air, if that makes sense to you, if you can picture the axes, and I will give you, I will show you quickly when we get to class so that you can see that. So again, we're taking a 3-dimensional idea and we're plotting it on 2-dimensional paper, okay? So with these grids, we're going to draw our axes like this. Okay, of course you're going to use a ruler. I can't seem to do that in this program that I make the videos with. And the other thing that I just need you to understand is that obviously this is just a way to do it, but this distance here is not really the same as this distance right here. We know that from Pythagorean theorem, but we're still going to say that this is a scale of 1 to 1. Okay, and so this right here would be 1, 2, 3, and of course here we have our -1, +1 in the z-axis. Let's say 2, sorry, that should be the y-axis, very important there. And -2, for instance, right here. And for our x-axis, this is our negatives. Okay, so hopefully that makes sense to you. That's what I have found to be the easiest way for people to actually plot this and draw this on 2-dimensional paper. This allows you to sort of just count boxes, which I know you like. Okay, so let's start off. We're going to do A. Okay, so we're going to plot the point 2, 4, 3. Just a reminder that that's our x, y, and z. Okay, so I'm going to do a dotted line so you can trace my path. I'm starting at the origin, and I'm going to go 2 on the x. Then I'm going to go 4 on the y, so that means 4 boxes to the right. And then I'm going to go up 3 boxes for the z. Okay, so this is the point right here. That's my A. 2, 4, 3. Remember, that's really, you have to picture that that's sort of up in space, right? It's not actually on that grid. This is a 3-dimensional idea being drawn in 2D. Okay, now I'm going to show you how to draw the box, okay, that goes along with it, because that is mandatory. You do have to draw the box. Okay, so I'm going to start again just so you can see. So when I started right here with my blue dotted line going out 2, that was me creating the bottom of the box. Okay, and then I went over 4, and that, if I make that a parallelogram, or right there, that is the bottom of the box. Can you see that? And can you see how on the x it hits at 2, and on the y-axis it hits at 4? Okay, now the height of the box, if you like, is 3, the z. So from all of those corners of the bottom of the box, you can just go up 3. This one's already done for us because we did our point. This is the back, this is the front corner, and that creates the parallelogram for the top of the box, if you can see it. Okay, and this will require some practice. It's very important that you draw the box each time, and you do this on grid paper, and you give it some time to actually practice. Okay, we're going to try a few more. Okay, so here's my setup for B. Just make sure you've set it up yourself as well. These next couple are a little bit different, and then you'll try D all by yourself. So with B, you'll notice that the x-coordinate and the y-coordinate are 0. So if I'm starting at the origin, I'm not going diagonal at all, or out of the page and in the page. I'm not going to the right or left at all, and all I'm doing is going up 4. And so really B is just on the z-axis. okay, up 4. Okay, so really this is actually a z-intercept if you like. As we move forward, that will make more sense to you. Okay, so that's sort of a special one. There's no box to be drawn because the point is literally on the z-axis. Let us set up the next one. Okay, so with C right away, you'll notice that this is a point on the xy plane. The z coordinate is 0. So starting at the origin, you can follow my red dotted line. We're going to go out 2, so 2 on the x-axis. We're going to go to the right 3 boxes, okay, and up or down 0, so that actually is our point right there. Now in terms of making our box in this case, because it's only in 2 planes, it's really just the bottom of the box if you like, or non-3-dimensional and 2-dimensional because it's only in 2 planes. And hopefully you can picture that as sort of a flat parallelogram there. Okay, so that's C. Why don't you go ahead and set up D and try that one on your own. Okay, so I'm going to start by just using a red dotted line to show you my pathway. So the x-coordinate is -1, so it's like we're going backwards or into the page, -1. Then -3 for the y, so that's like left 3. And up 4. Okay, again, the easiest way to take this idea and plot this 3-dimensional point in 2 dimensions. Okay, so there's our point. Let's work on our box. So I'm going to retrace my steps in blue. Okay, I went back -1, -3, and remember that this hits on -1 on the x-axis, and then that hits on -3 on the y-axis. That, hopefully you can see it, is the bottom of your box. Okay, and from my -3, then I'm going up 4 for the z, so every corner for the bottom of the box, you're just going to go up 4. And here I am on the y-axis, up 4. Again, it hits. And there's the top of the box that I'm shading in. So I can shade in the top of the box. And hopefully you can see how the top of the box is at +4. Okay, so that's our box right there. Okay, so you're going to need to practice this idea. Okay, so that was plotting points, and now we're going to look at algebraic vectors, drawing the vectors, okay? And just like with 2 dimensions, okay, any vector can be placed with its tail at the origin, and then its head will fall on some point P that we've been plotting with these coordinates. Therefore, then the ordered triple that looks like this with square brackets around it represents an algebraic vector starting at an origin, going to a point P, which is A, B, C. So this is what we call a Cartesian vector. A Cartesian vector. So in this diagram over here on the right, you can see that the vector starts at the origin and it goes to the point P. The point P is A, B, C. And the vector, we can call the vector, let's say, U, vector U, or we can call the vector OP. Or we can also write it now as A, B, C with square brackets around it to indicate that it's a vector. The unit vectors in 3 space are similar to that in 2 space, in that unit vector I can be written as 1, 0, 0. That would be that vector right there, okay, with magnitude 1. That would be I. Unit vector J can be written as 0, 1, 0. And that would be this vector right here. And vector K is 0, 0, 1. And that would be this unit vector right there. And we know that all unit vectors, the magnitude of I is equal to the magnitude of J. It's equal to the magnitude of K. They all equal 1. So similarly, in unit vector notation, we can write vector U. This is what we're calling vector OP or vector U as A times unit vector I plus B times unit vector J plus C times unit vector K. So this is our, remember, unit vector notation. And just like we did in 2 space, if our vector is a comma b comma c, then we can find the magnitude of that vector, so the magnitude of vector u, by taking the square root of a squared plus b squared plus c squared. Okay, so one more idea that I just want to mention. We won't do too much with this, but in 2 dimensions, we describe the direction of a vector by a single angle. In 3 dimensions, there are actually 3 different angles that we use to indicate the direction, and so these are called direction angles. And you can just see here in the diagram and in the box that we call those angles alpha, beta, and gamma, and they're the angle that the vector makes with each axis, the x-axis, the y-axis, and the z-axis. And all of these angles would, of course, be between 0 and 180 degrees. We're not going to calculate those at all, but it's just important that you know that they're called direction angles. Okay, so let's see if we can put it all together and try an example. Okay, so for this first question, we are going to sketch this position vector. We're going to express the vector as a sum of the unit vectors I, j, and k, so in unit vector notation, and we're going to determine its magnitude. So do yourself a favor, pause the video here, set up your grid, and at least try to plot the vector, i.e. plot the point, and then we'll take it from there. Okay, so looking at plotting this vector or this point in my dotted red line from the origin, I'm going to go 3 on the x. Okay, we can also label that. I'm going to go -1 for the y, so that means 1 box to the left. And then I'm going to go up 2. Okay, so this is the point, if you like, 3 comma -1 comma 2. And the direction vector is the vector from the origin to that point. You're, of course, going to use a ruler for all of these lines. So that's the direction vector. I'm going to just go back and trace my steps and draw the box in. You do need to do that every single time. I'm going to draw it in green. So again, I'm going to trace my steps from the origin. I went out 3 on the x and then left 1 for the y. So that's the bottom of the box. Okay, note it hits y at -1. And then from each corner of the bottom of the box, I'm going to go up 2. So up 2, up 2, up 2. And that, hopefully you can see, is the top of my box there. Okay, and again, this is your vector. Let's say that that's vector u. So vector u equals 3 comma -1 comma 2, or in unit vector notation, it's 3i minus j plus 2k. Okay, and for the magnitude of our vector, the magnitude of u, or you could write the magnitude of this vector, you can write it either way, it doesn't matter, I just wanted to show you the different ways, would equal 3 squared plus -1 squared plus 2 squared, and that would give you the square root of 14. Okay, so that's the magnitude of the vector. So hopefully that makes sense. You go ahead, pause the video. I want you to try B all by yourself. Okay, so check your work for B. Just make sure if you do have any questions, you bring those to class. And the last thing I just wanted to make sure that you had is, just like with 2-dimensional vectors, the vector connecting 2 points in 3 space is simply found by subtracting the x, y, and z coordinates respectively. Okay, so in other words, if we have a vector A, A1, B1, C1, and a vector B, A2, B2, C2, then vector AB would simply be A2 minus A1. That's the first coordinate, the x coordinate if you like, comma B2 minus B1. That would be our y coordinate, and C2 minus C1, and that would be our z coordinate. So you're going to do some practicing, and then we'll continue on together.